Welcome to an Apprenda quick demo. My name is Ike Arias, and today I am going to show you how you can attach an OpenShift cluster to an Apprenda Cloud Platform instance. The Apprenda Cloud Platform has supported Docker-based deployments for a while, but for the last year and a half or so, we've been aggressively adopting and integrating Kubernetes into almost everything we do. Starting with ACP version 7, you can attach a Kubernetes cluster to the Apprenda Cloud Platform as an optional cluster manager and resource provider. Rakesh Malhotra, Apprenda's Senior VP of Product Strategy and Development, recently recorded a detailed demo of this functionality. I encourage you to watch it when you get a chance. We will post a link to it in the description below. In this quick demo, we will explore a more specific combination, attaching an OpenShift cluster to an ACP instance. As you probably know, starting with version 3, OpenShift is based on Kubernetes, and we can therefore attach the underlying cluster to ACP just like we do with generic Kubernetes clusters. This means that OpenShift customers can now enhance their OpenShift clusters with Apprenda capabilities in a unified architecture, and we will see an example of how valuable this can be. So let's dive in. Here you can see that we have previously configured a simple single-node OpenShift origin instance for this demo. The OC version command confirms that this is a recent version of the product. If I use the kubectl client, you can see that I can access the underlying Kubernetes cluster directly. The cluster info command shows that we're connected to the same API server, and the version command confirms that we're talking to a version 1.6.1 server. Let's examine the cluster state by retrieving some useful information. These are the OpenShift projects, which are basically Kubernetes namespaces. We can also retrieve a list of all the pods that are currently running. Now, let's attach this cluster to an existing ACP instance. This is the ACP System Operations Center, or SOC for short. If we navigate to the infrastructure screen, we can see all the nodes that are currently attached to the platform. We'll go to the cloud screen now to attach the OpenShift cluster. In this case, we'll use a certificate-based authentication mechanism since this is how OpenShift sets things up. ACP then runs a set of tests to validate the connection information and the proper functioning of the target cluster. Once configured, I can now see the OpenShift origin node in the infrastructure table, properly denoted by the letter K for Kubernetes. If this were a full cluster, we would see here all the nodes. If we now go back to the command line, we can see that ACP has created its own namespace to organize ACP workloads, which shouldn't interfere in any way with existing projects or apps on that cluster. Now let's consider a hypothetical but very realistic example of an enterprise development team that is tasked with modernizing an existing application. The actual example app that we will use for the demo is very simple, but the concepts we will illustrate are extremely powerful. So in this hypothetical world, I have a legacy .NET WCF web service that provides the basic access semantics for an underlying SQL Server Guestbook database. It allows us to store and retrieve Guestbook entries by calling a simple API. The existing app works fine for the most part, but the old user interface is clunky, and the business wants a shiny new HTML5 based front end to better compete in the marketplace. There is nothing wrong with the web service middleware or the database, so there's no need to rewrite those pieces. The team has come up with a new architecture that replaces a front end with a Node.js app running in Kubernetes that communicates with the legacy WCF web service. Let's see this in practice. In this archive, I have an app consisting of 3 components. There is a database schema definition file that leverages ACP's Database as a Service feature to create a relational database on the fly. The schema itself hasn't changed at all, just the way the database itself is provisioned is much more convenient with the platform. There is also a services folder containing our legacy middleware .NET code written in C#. As you can see, these are binary files, compiled code that may come from a completely different team, or for which we don't have the original source accessible. No code changes were necessary, and only a couple of configuration changes allow this part of the app to now be cloud enabled, as we'll see in a minute. Finally, I have a pods folder where we dropped a Kubernetes resource definition file for our new Node.js front end. This component references a Docker image that was built by a CI/CD server and uploaded to an authorized registry. Notice that we can use ACP's features here just like with any other workload type. In this case, we're using token replacement for deployment time variable substitutions. To deploy this new application, we must create an application definition and upload the archive to the platform. We will use the HTML developer portal for this demo, but you can also use the REST API or command line client or any of the other mechanisms for interacting with the platform. Once uploaded, we can examine the application definition. We can see that ACP has properly recognized the 3 different components and has assigned default resource policies to each. It's important to note that these components have not yet been deployed and our application is not running yet, as denoted by the definition stage marker in the top right of the portal. I don't really need to configure anything further, so I'll just go to the dashboard screen and promote the application. This is what tells ACP to proceed with the actual deployment of all the components and actually start the application. This promotion report card informs us of all the actions being taken by the platform and the time spent in each. For our particular app, ACP is dynamically provisioning a SQL Server database and initializing it with the schema definition that we provided. It is then deploying the WCF legacy service component into an Apprenda custom Windows container and using token replacement to properly configure the database connectivity for it. Finally, it coordinates the deployment of the Kubernetes replica set with the Node.js front end onto the Kubernetes cluster. Within a few seconds, we have our cluster-enabled application up and running, and we can immediately see it working by visiting its dynamically assigned URL. The Guestbook front end displays a simple text field that I can use to add entries into the database. You can see the persisted entries at the top with their corresponding unique identifiers, confirming that they are actually stored in the SQL Server database. If we now examine the Kubernetes cluster directly, we can see the existence of a new replica set and corresponding pod. We can also see that a corresponding service has been created for it. Let's suppose that the new application has suddenly become very popular, and the small front-end container cannot serve all the incoming requests fast enough. We can simply use Apprenda's scaling feature to control the underlying replica set's replica count. By adjusting this slider in the developer portal, ACP informs the Kubernetes cluster about the app owner's new requirement. In a few seconds, we can see that there are now 2 pods powering the front end. We can just as well scale the middle tier if it ever becomes a bottleneck. This legacy .NET component has now been cloud enabled without the need for any code changes. And that's it. We now have a revamped Guestbook application with a shiny new front end running in OpenShift. It should be easy to imagine how this pattern can be used to enhance or complement existing applications, or even the other way around, allowing new cloud-native microservices to easily access and consume legacy enterprise applications. If your company has already made an investment in OpenShift and you're trying to figure out how to manage your legacy app portfolio, there is now a great way to bring both together in a unified and coherent platform. Please visit us at www.apprenda.com for more information and for ways to get in touch with us. Thanks for watching.